Sleep, O sleep, in whom all things find rest, most peaceful of the gods, you who calm the mind, put cares to flight, soothe limbs wearied by harsh tasks, and refresh them for their toil. Man, I'm not gonna lie, I love a good night's sleep. It is a time when our body is refreshed, and it's an important field in psychology because more and more psychologists and physicians are understanding the really important role that both sleep and dreams has for us. So I would like you to open your packet and take the survey, pause the video, and take the survey of if you are sleep deprived or not. And I'll give you the results in just a minute. But as you're answering these questions, answer yes or no to each of them, and then count up the number of yeses that you have. Okay, so here are the results. If you had 1 to 4 yeses, you're getting the sleep that you need. One of the reasons why our high school starts at 8:30 is because of research that shows that teenagers in particular have a difficult time going to bed early and they need to sleep a little bit later in the day. And so I have found that the 8:30 start time is not only beneficial for teenagers, but for me as well. 5 to 6, you have some sleep debt, but you don't have any long-term problems due to sleep debt. Just on this particular day, you might be a little more in need of sleep than maybe if you scored lower. At 7 to 8, you're going to have moderate sleep debt. That means you're going to need to perhaps catch up on some REM time when you can sleep in. You might feel a little tired going through the day. But when we get to 9 to 11, we're starting to have large sleep debt. You're going to commit some errors due to lack of sleep. Your memory could be affected, your accuracy in driving, etc. And 12 to 15, I'm not kidding, guys. This is serious sleep debt. You may be accident prone. You will have memory problems. Your schoolwork will be affected. So this is really an important topic. I have had students that have scored 14 or 15 on this very simple test, which comes from the National Sleep Foundation. And it is obvious to me that they are not getting enough sleep. So you need to look at your sleep environment and make sure that it's quiet, that it's cool, that it's dark, that you have comfortable bedding, and just make sure that you go to bed at a regular time every day. That's really the best way to assure that you will take care of your sleep debt. And I really, really mean it. Do something to help with your sleep debt. All right, so how do we go to sleep? So we have in our retina, remember we have the rods and the cones? Well, our retina is pretty amazing because even in people that are blind, there are special cells that detect that darkness has come. So in a world without electric lights and things like that, these light detecting cells would start detecting the darkness as soon as the natural light darkened. And this is why it's so important for us. We are in an electric world and we do have lights at night, but we need to have them off when we go to bed because we need that darkness to get a good night's sleep. What this does is it sends a message to the suprachiasmatic nucleus, or SCN for short, which is in the hypothalamus. Remember that hypothalamus, really important for homeostasis and the 4 F's. The SCN sends a message to the pineal gland, and you can see it on the diagram on the top left. This is just behind the brainstem region, and this produces melatonin. Melatonin is a hormone that induces sleep. In fact, some people take melatonin supplements. I know that my mom takes them. Some people find them to be very helpful. Some people find them to make them drowsy the next day or give them bad dreams. So they are over the counter, they're not prescription, and that's something that's out there. In the morning, light enters the retina, melatonin production decreases, and you wake up. You might notice here in Minnesota, if you're camping or something and the light is, starts streaming in your tent at about 5 in the morning, you can't get back to sleep. That's because your melatonin production has dropped. So that's the basic cycle of going to sleep. Now, there's a video here that I'm going to post on Schoology, and I'm going to recommend that you watch that, because what it does is it talks about why we sleep. But let me just summarize quickly. We sleep to recuperate and remember. During sleep, our body tissues actually have cells that are sent towards them. And this is the time of day where we have the most restoration of our body tissues. We also have an increased production of immune cells during sleep. If you go through a time period in your life that's incredibly stressful and you're not getting a lot of sleep, it is possible that you're going to be more prone to infections and illness because you are not getting the immune cell production that you would normally get. And it helps us to reorganize and consolidate our memories. And this is what's really obvious on the video from Scientific American that I would like you to watch. The other thing is growth. The pituitary releases growth hormone during sleep, and that is a picture of my puppy. She's not a puppy now, she's 5 years old, but even puppies release growth hormone during sleep. Okay, so our body operates on circadian rhythms. Circa means about, and diem means day. There are 24-hour to 25-hour cycles that control both your sleep and wake cycle, your body temperature, which will vary throughout the day. It will generally be its coolest in the morning when you wake up, and your hormone levels. Your heart rate also goes through regular changes throughout the day. And if any of you have had something called a Holter monitor, which is where they might be looking for some kind of problem with your cardiac rhythms, this would measure maybe up to 48 or 72 hours or even more, and you would wear a heart rate monitor. And it's really clear when you see the readout of the EKG, the rhythms that your heart goes through throughout a 24 to 25-hour cycle. So the sleep cycles, turn to the diagram that looks like this in your packet, and I would recommend that you draw the diagram as you see it here. Okay, so first of all, stage one. Stage one is characterized by these what are called alpha waves here. Okay, so they're kind of like awake, sort of, but not really. So, and this is another example as well. So this is drowsy, and this is stage one. 1 to 7 minutes, and they're called theta waves. During this stage, you might experience something called a hypnic jerk. That is that feeling that you're laying down and then all of a sudden, boom, whoa, like your whole body jerks. And it's kind of fun in class to hear students talk about how that happens. Some people feel like they're falling and then they get, abruptly awoken. And I'm pretty sure most of you know what that is. Some of you may have experienced something called hypnagogic hallucinations. These are just like bright colors or flashes of light that some people see as they're falling asleep. And by the way, I forgot to mention, these are actually EKG brain waves. And then if you're having a sleep study done, you'll also have an electrode placed on either side of your eye, on your chin, and on some other muscles as well. Right now, I'm talking about the brain waves, however. Stage two. Stage two sleep. This is the onset of true sleep. How do we know? Well, what you'll see is that the muscle tension loosens, the heart rate is slower, your body temperature is decreased, and your respiration goes to slow and steady, deep breaths. I can always tell when my husband is entering stage two because of that respiration. The other thing that happens during stage two is eyes move slowly side to side, not quickly like we have in rapid eye movement, which we'll talk about in a minute. We also experience something called sleep spindles on our EEG, and these are tightly bound spindles, kind of like thread, that we see characteristic of sleep to sleep. This is how, if you're having a sleep study done, the researcher will know that you have indeed gone into true sleep. Now, sometime during stage two, you'll start getting these waves here, which are K complexes, which indicate that you're going into a deeper level of sleep. So stage 3 and 4 together are called slow wave or deep sleep. And here, this diagram is slightly different than the one that you have, But your brain waves are going to look something like this. This is our restorative sleep. This is when that immune cell production occurs. This is when hormones are released. This is a really, really important time of sleep. If someone has a sleep apnea, which is a sleep disorder, and they are woken up constantly before they reach stage 3 of sleep, they are potentially going to have problems with immune cell function or healing from injuries. We must go into our deep sleep or slow wave sleep. And stage 4 is when funny things happen in the night. And I'm going to talk about that in just a minute. But I'd like you to look at this first of all. This is a typical way that a sleep chart is depicted. So we spend, just about 5 minutes or so in stage 1. And then we spend just a few minutes in stage 2 the first time around. And then we go to stage 3, and we're going to see these bigger delta waves. And, we might spend, 20 minutes or so there. And then we go into our deepest sleep, stage 4. And that's going to last about 30 minutes. We go back up about 3 minutes, about 5 minutes, and then we go into our first REM, which I'm going to talk about in a minute. So stage 4, interestingly, is where sleepwalking and talking occur. This is where I wish you were really in class, because the stories I hear about sleepwalking and sleep talking are hilarious sometimes. People walking across the street and going into their neighbor's house and, sleeping on their couch and then waking up and thinking, why am I here in the morning? Night terrors is another thing that happens in stage 4. And keep in mind, night terrors are not nightmares. They are different. Nightmares are bad dreams. Night terrors is merely a high activation of the central nervous system, of the autonomic nervous system in particular, in which somebody sits bolt upright, they scream bloody murder, and then someone, will come to them and will hug them or shake them. It's okay to wake someone up during night terrors. It is not a problem unless it is something that lasts, late into childhood or teenagers, but it is quite normal among young persons. Okay, so REM is depicted by this thicker line or the blue line here, and we can see that by the 3rd and into the 4th hour of sleep, we go down into stage 4 one more time, and then we're done for the night. We go back up again, we come down, we go to stage 3 one more time, and then the last half of the night is merely going back and forth between REM and stage 2 until we wake up. The best time to wake up, by the way, is during REM sleep. That is when we'll feel most rested. Now, I'd like to point out that the sleep cycle is generally divided into 2 parts. The first part, this is going to be that restorative sleep, really important for that. The second part is going to be more important for memory consolidation. Now, REM plays a specifically important role for us as humans, and we really do need our REM sleep. If we don't have REM sleep, it's shown in most studies that we can have organ failure. So what happens during REM sleep? Well, this is a fascinating stage of sleep. First of all, your heart rate, your blood pressure, and your respiration increase. We call this paradoxical sleep because while your muscles are paralyzed, your brain waves are similar to active alert. People during this stage of sleep experience something called sleep paralysis. Now, if you were in class, I would guarantee you there would be at least a couple of people in class that have experienced that feeling that they wake up and they can't move. And it's a really scary experience the first time. Why does this happen? Well, you might remember that the pons sends a message to the motor cortex that tells the motor cortex, don't move during REM sleep. And if your pons has not gotten the message yet that you are awake, you might have that moment of sleep paralysis. People describe it as a feeling of somebody sitting on them, and many people around the world experience an apparition of some kind. The top picture shows like a demon on the chest of a woman who is in REM sleep, Some people will see a hollow-looking apparition like the night hag or ghost that you see in the second picture. And I can't tell you how many stories I have heard through my years of teaching this course of people that have had these kind of apparitions. And they are common to man. They are all around the world, and people have come up with different stories about them. But the reality is that they're just a process probably left over from our evolutionary past. We don't really know why, but it is believed by scientists that they are not actually ghosts or demons visiting you, that they are a process that occurs in the brain. And I think once people know that, they can set those fears aside that they might have about these visions. And I have had people come up to me after class and tell me that they, in their culture, have been told that perhaps it was a demon or something like that. And you just don't need to worry about that. Please do know that those are common. The most vivid dreams that we have occur during REM sleep. Some dreams are in NREM or non-REM sleep, about 20%, but our most vivid dreams, and about 80% of our dreams, do occur during REM. And they tend to be in full color, and we're going to talk about dream theories tomorrow, but they are really vivid, wonderful, fantastical visions. Memory consolidation occurs during REM sleep, and this has been illustrated by numerous research studies, one of which is the Scientific American video that you're going to watch after you watch this one. REM stages do get longer in the second half of the night, so that's when the memory consolidation is going to occur. And then here's an interesting concept, and one that you need to know. REM rebound is what occurs if you're deprived of REM. So let's say you have a week or two where you have to get up early every day, or you have to stay up late every night, and you're not able to get the REM sleep that you would normally need, that your body needs. We have a preset amount of REM that we need. Well, what happens when you are allowed to sleep? You will make it up with longer and more frequent REM. I've noticed this in myself. If I have a number of days that I'm getting up early and then I'm able to sleep in on the weekend, that I have these just wild, long REM periods. And so again, we do know that REM sleep is critical. We know the things that it does. And overall, sleep has been a fascinating area of study for about the last 70 years when the changes in brainwave patterns were first discovered. So have a good night's sleep tonight, and read the text and watch the Scientific American video. All right, take care, everyone.